Hello, today we're going to be going over the FlyPi for the MicroCart project. And specifically what we're going to be going over is how the big quad deck on it kind of works and how to replace it pretty much. And so the current way that it works is there is just a big Crazy Fly with a big quad deck strapped on top of it with the motors removed on top of the FlyPi, with this thing being the FlyPi. And yeah, basically we just have it zip tied down. There's some firmware changes that were made to make this work that we'll go over later in the video. But first, we're just going to go over how to replace the Crazy Fly. So, let's get to it.
This Crazy Fly was damaged in a fall, and so through the course of this video, we will be replacing and flashing it with new firmware. The big quad deck reroutes the outputs of the motor PWMs into the ESC input. When hooking the wires from the big quad deck up to the ESC, it's important to make sure they are routed to the right corner. A good way to test this is once the quad is running, you can lean it to one side or another in order to check if the motors are thrusting in a way as to compensate for its tilt, and swapping two motors at a time until it's doing the right thing. As you can see, the issue with this Crazy Fly was that one of the legs broke off, which disabled the red flashing LED. While it is still able to fly, we wanted to replace it so it would be easier to identify issues using the red light. One thing that had to be fixed was that one of the pins was soldered onto the big quad deck because it had a hard time staying in contact without being soldered. So I grabbed a new pin to replace this one, which is what you see me doing here. With it all fixed, make sure that you align the direction of the Crazy Fly and the big quad deck. They have arrows going in the same direction. Now the next step is to zip tie it all down. I try to have the battery wires line up facing the same direction. The Crazy Fly and big quad deck are now physically set up and ready to go. So before we go any further, we need to do some software stuff. There were very few changes that actually needed to be made for the FlyPi ESC to understand the Crazy Fly PWMs. The only difference comes in the startup procedure, where rather than playing the usual tones, we instead send high and low speed thrusts to the ESC for each motor channel, with the high thrust signal being sent for 2 milliseconds and the low thrust signal being sent for 20 milliseconds. The only other software change here is that there is a motor convert 16 to bits MicroCart 23 function, but this does not do anything differently than the regular brushless motor bit conversion function. This function basically just scales the input so that the max thrust is at most 2 milliseconds of the 2.5 millisecond period, and zero thrust is 1 millisecond. The next change is in the Crazy Fly supplied config.make file. A C flag needs to be enabled in order to enable the big quad deck. Once this is included in the config.make file, you can just make like normal, which is what we will do next. In order to build the big quad deck Crazy Fly firmware, change directories into the MicroCart folder and then into the Crazy Fly software big quad folder, and once more into the firmware folder. Finally call the make controller equals student command to build the software. You shouldn't see any major errors unless you changed something, or if something isn't configured right. If you run into these issues, Google is your friend. But once the software is built, it is time to put the drone into bootloader mode. To do this, press the power button on the front of the drone once, and the LEDs should all turn off. Press the button again and wait for the blue LED to start blinking. Now release and the drone is in bootloader mode. Back on the computer, run the make cload command, and so long as the Crazy Radio is connected properly, the firmware will begin to flash. This should only take a minute or two. With the firmware all flash, you'll want to put the battery in the holder. The best way to do this is to turn it sideways because it will be snug enough to not fall out. Now it is time to run the Python 3.10 MicroCart.py command to launch the GUI. This MicroCart GUI is the only one that is safely compatible with the FlyPi as of right now. Click Scan to look for the Crazy Flies and FlyPis in the area. Once it pops up, select the one you want while selecting it as a FlyPi and click Connect. By selecting it as a FlyPi, this will limit the max thrust, pitch, and roll that it can receive. The next thing to do is to configure the gamepad. In order for the gamepad to work, it needs to be connected to the computer prior to launching MicroCart. But to configure the gamepad, click Configure and then select Generic OS X. This uses controls flipped from how I like it, so I clicked Detect in order to detect the axis that I want to set to being thrust on the joysticks. I then did this for all the axes and clicked save. Back on the controls page, if you select a few logging signals, you should be able to see incoming data. If yaw, pitch, and roll are selected, a good way to make sure everything is configured right is to wave the drone around and see if the data updates correctly. With that, we're almost ready to fly. When you are new to the drone, in order to be safe, you should tie it down to a brick. This will help prevent you running into another person, or from falling so far as to break the drone, or from running it into the ceiling. Basically, in general, it's a good idea to tie it down while you're learning. Back in the GUI, once the drone is tied down, just click the gamepad mode to start flying, and use the gamepad. And with that, you are back to a working drone. Thank you for watching. I hope this video has been helpful to you. Have a great day.